Lesson 11.3, geometric sequences. We've talked about arithmetic sequences, arithmetic series. Now we're going to talk about geometric sequences and then geometric series. Geometric, unlike arithmetic, is a sequence created by multiplying a term by a common ratio or a constant ratio to create the next number in the sequence. So a sub n can be found by taking r times the one right before it, a sub n minus 1. Notation-wise, that means this. If this is the a sub n term, then this is the one right before it, which is one less. So if this was the a sub 9th term, this would be the a sub 8th term. And so n minus 1 represents one less. Here I have a question about what's next. Well, to do so, we need to find r. In arithmetic sequences, we needed d for common difference. Here it's ratio. So we take a number, not the first one, and divide it by the 1 to the left of it, or 1 just before it, means the same thing. Or I could have chosen 36 and divided by 108. Either one works. Either one should give you the same answer. That's why it's considered a common ratio. And it should be 1/3 for each one. Now once you know that your ratio is 1/3, you'll use it and take it times the 1 times 12, the last term you have, to get the next one. And that would be 4. Another equation we need, okay, this is called the explicit formula to find a particular term. If I want to find the nth term, I need to know the first one, I need to know the common ratio, and then I have n minus 1 power. So let's try that. We're looking for the 6th term. So a sub 6, we know the first term, it's -3. We know our r, and if it's the 6th term, it would be 6 minus 1 up here. In other words, 5. So we can find this by taking -3 times -2 to the 5th power. And that would give us 96. So with this information, your 6th term would be 96. Write the equation for the nth term. Write the equation for the nth term of a geometric sequence. Here's our order. So if we look at this, what is r? Well, 10 divided by 5, 20 divided by 10, our r must be 2. Okay, so our equation would be a sub n equals our first term, our r is 2, and n minus 1. And this is considered our equation for the nth term. Find the term given the 4th term and the ratio. Now in this case it's written wrong, it should be 3rd. So we have 7th term, find the 7th term of a geometric sequence in which we know this information. So if we take a sub 7 equals a sub 1, our first term, which we don't know, r is 2, we take that to the 6th. So we still need our a sub 1. But we know that our 3rd term is 96. So I'm going to write 96 equals our first term, unknown, a ratio of 2, and 96 is our 3rd term. So 3 minus 1. And we get 96 equals a sub 1 times 2 to the 2nd power. And we can solve this for a. So in other words, we're going to divide it by 2 to the 2nd, which we know is 4. And a sub 1 is 24. Which means we can take this information back to here and get a sub 7 equals our first term times 2 to the 6th. So 24 times 2 to the 6th is 1,536. That is our 7th term. The last piece we're going to talk about is geometric means. We said that arithmetic means were terms between two non-consecutive terms in a sequence. Here we're told that there are 3 of them. So we have 3.12, 1, 2, 3 terms. Then we have our last one, 49.92. What are those terms? So we need to find R. So let's take a look at finding a way to find R. Let's use a sub n equals a sub 1 times r to the n minus 1. We have this term, which is 1, 2, 3, 4, the 5th term. So 49.92 equals our first term, 3.12. We said it was our 5th term, so it's 5 minus 1. And we can solve this for r. So we have 49.92 equals 3.12 times r to the 4th. Divide both sides by 3.12. We get 16 equals r to the 4th. 4th root of that will give us 2, but we have to remember something. It's plus or minus 2. 4th would give you 16 if you took it to the 4th power. So what does that mean? Well, if r is equal to 2, then we have 3.12 and then what do? 2 is our r, so we multiply, don't add, unlike arithmetic, and we get 6.24 times 2, which is 12.48, times 2, 24.96, times 2, and you will get 49.92. If r is equal to negative 2, then we take it times a negative 2, so now all of a sudden our numbers will alternate signs. So it still works out, but we have alternating signs in our sequence. So we use this formula quite a bit. This ends lesson 11.3.